welcome back. So what we're looking at today is 2.10. I've got to fill in. This is the last lesson in chapter 2, so you will be doing a chapter 2 test next week, not this week. You'll have the review this week, but chapter 2 test will be next week. So just a little heads up there. So let's go ahead and jump right in. A golf pro practices his swing by driving golf balls off the edge of a cliff into a lake. The height of the ball above the lake, measured in meters, as a function of time, measured in seconds, and represented by the variable t, from the instant of impact with the golf club is 58.8 plus 19.6 t minus 4.9 t squared. So quadratic equation just kind of flipped around. Instead of having the squared term first, it's got the constant term first. The expressions below are equivalent. So we've got standard form, factored form, and vertex form. So our three different forms that we have for a quadratic equation. So negative 4.9 t squared plus 19.6 t plus 58.8. Negative 4.9 times the quantity t minus 6 times the quantity t plus 2, which is our factored form, and then negative 4.9 times the quantity t minus 2 squared plus 78.4. That's our vertex form. So for number 1, which expression is the most useful for finding how many seconds it takes for the ball to hit the water? Why? So first of all, what does it mean when the ball hits the water? If we were thinking about having an actual graph of this, at what point would it be hitting the water? It'd be hitting at 0. The water would represent 0, or the x-axis, which means we want to know what the x-intercepts are. So which of these three equations shows us the x-intercepts the easiest? That'd be factored. So remember from last time, when it's in factored form, finding those x-intercepts is it's the opposite of each of these two values. Those are your x-intercepts. So factored form connects, made a weird C there, connects to x-intercepts. All right, for number 2, which expression is the most useful for finding the maximum height of the ball? So if we think about maximum height on our parabola, the maximum height is going to be what point? What is always the maximum of a parabola, depending on the direction it's going? In this case, we've got a negative, so remember it's going down like this. So where's that maximum point, the topmost point? It's at the vertex, which means using the vertex form is going to tell us what that value is. So vertex, because it is your max or min value. So your vertex is always going to be either your maximum or your minimum value. So being as we're looking for the maximum value, we know we're going to want to go for that vertex. So you guys are going to answer questions 3 and 4. So it's just like what we're doing here. Which equation is going to be best suited to take and answer the question given? All right, the next part, finding multiple representations of a quadratic. One form of a quadratic function is given. Fill in the missing forms. So we've got standard form, vertex form, we've got a table, we've got a graph, and we have factored form. What we're given in this one is factored form. So we need to take and convert it to standard form and then vertex form, and then we'll take and have our table, and then we'll graph it out. So we have x plus 5 times x minus 3. So if we take and FOIL these, use FOIL to multiply them, x times x is going to give us x squared. X times negative 3 is going to give us minus 3x. Positive 5 times x. So we multiply the 5 and the x to get our 5x. And then we do 5 times negative 3 to get minus 15. We combine like terms. So we have x squared. Negative 3 plus 5 is going to give us a positive 2x minus 15. So our standard form is y equals x squared plus 2x minus 15. So that's our standard form. Now, to find vertex form, we have to take and complete the square. So for this, I'm going to erase this over here so I have some more space. We're going to take our x squared plus 2x minus 15, and we're going to group the first two together. So we're going to have x squared plus 2x, leave some space, minus 15. And then we're going to take our middle term, so our b term, divide it by 2, so we get 1. 1 squared is still 1, so we put that there. We put minus 1 out here. Then we're going to have x plus 1, because this one comes from there down to there, squared. And then negative 15 minus 1 will give us negative 16. So our vertex form, sorry, not factored form. Our vertex form is y equals x plus 1 squared minus 16. So now we know what the vertex is, and we know what the x-intercepts are. So we can graph this. So we are at negative 1 and negative 16, which this is in 1, 2, 3, 4, 5, 6, 7, 8, 9. So we're going to double this. So this will be my negative 16. And let me make that a little bigger so you can see it. So I am doubling my y-axis. So this is 2, 4, 6, 8, 10, 12, 14, 16. So just a heads up there. So this is my vertex right here. We know we have an x-intercept at negative 5. So 1, 2, 3, 4, 5. And we have another one at positive 3. So 1, 2, 3. So there is our parabola. I'm going to attempt to draw the curve through this. Obviously, you guys will have a little bit easier time than I will. So our parabola should look something like this, a little more rounded and less rigid, but similar. So for the table, we need to take and look at what our values should be. So we know we need the point negative 1, negative 16. Because that's our vertex. And then we need points to either side of that. So negative 2, if we plug a negative 2 in here, negative 2 plus 1 is negative 1. Negative 1 squared is 1. 1 minus 16 is negative 15. So that means at 0, we're also at negative 15. And then we need one more to the other side. So we're going to do 1. So 1 plus 1 is 2. 2 squared is 4. 4 minus 16 is negative 12. So over here at negative 3, it'll also be negative 12. Sorry, I didn't have quite enough space there. But so there's our table. So you need to have the vertex and then 2 points to either side of it. Remember, your points, your y values are going to have the same thing. Notice you're at 16, there's 15 on either side, then there's 12 on either side. Those values should be symmetrical, so it should be easy. You'll only technically have to do 2 points and then do the symmetry to the other side of it. Okay? All right, so that's what you guys are doing on 6. You're given the vertex form. You need to go to standard and factored. 7, you have standard form. You want to find vertex and factored. And I will tell you, sometimes your vertex form and your factored form are going to be the same thing. So if from your vertex form there is no other way to factor it, because sometimes that might happen, then that's your answer. Sometimes that happens. So they can be the same. Then here on number 8, you're given the graph. So use what your vertex is, use your y-intercepts, your x-intercepts to help you come up with your form. And then for number 9, you do not have to do factored form. You don't have to worry about that yet. So all you have to do is standard and vertex form from the table. Remember, look for the one that has the symmetry to either side of it. Hint, I just gave you the vertex. All right, so the next part. Verify each factorization by multiplying. So what we want to do is we're going to multiply the x plus 16 times x minus 4 to see if we get x squared plus 12x minus 64. So x times x is going to give us x squared. X times negative 4 will give us minus 4x. 16 times x will give us plus 16x. And 16 times negative 4 will give us negative 64. Negative 4 plus 16 will give us positive 12. So we have x squared plus 12x minus 64. So yes, we verified. They are the same. So that's what you guys are going to be doing. You're going to be showing that these work out to be the same. And yes, I want to see your work because you're verifying. So I need to see that you've done the work to show it. All right, the last part, factor the following quadratic expressions if possible. So I will tell you 3 of these are not possible to factor, okay? All right, for number 4, we have x squared minus, 14, x squared minus 5x plus 6. What 2 things multiply to give us 6 and add to give us negative 5? Now, some of you might be thinking negative 1 and 6, but notice we have to have 2 negatives because 6 is positive. So that means we need negative 2 and negative 3, which will give us negative 5. So we're going to have x minus 2 and x minus 3. So be careful with that. For number 17, m squared plus 16m plus 63. So thinking about factors of 63, what 2 things multiply to give us 63 and add to give us 16? Hopefully you guys are thinking about 7 and 9. So x plus 7, x plus 9. They're all positive because both 63 and m are positive. And the last one I'm going to do with you guys, 18. S squared minus 3s minus 1. What 2 things multiply to give us negative 1 and add to give us negative 3? There's nothing, right? Because the only things that multiply to give us negative 1 are 1 and negative 1. That's it. And that doesn't get us to negative 3, so does not factor. So D and F. So that's what you can write when you get one that does not factor. So there's one of the 3 does not factor. So that means you have 2 others that will not factor in here. The rest of them are factorable. So make sure you get those factored right. If you guys have any questions, feel free to ask. Your keyword for this lesson is factor. Factor is your key word for this lesson. Have a good day, guys. Bye.